Good afternoon. Good afternoon. All is well. Hope everyone's doing all right. Just waiting for everybody to get in, and then we will get rolling.
Hello.
How's it going? How's it going? All right, looks like pretty much everyone's in. So let's go ahead and get in there. The last class, so we should be looking at 5-4. Okay. All right, so let's look at 5-4 today. Okay, so 5.4 trig functions are real numbers. All right. If t is a real number and p is the ordered pair xy, and that's the point on the unit circle that corresponds to t, then we have these right here. We talked about the relationship last class. It's really leaning on the same thing. Remember, I told you before that we were getting to the point where cosine most definitely is just x and sine is y. And so these are our same relationships. Cosecant and sines are inverses of each other. Cosine and secant are inverses of each other. Tangent and cotangent inverses of each other. And we talked about tangent being sine over cosine, so that would be y over x. Cotangent, inverse of that, cosine over sine, that's x over y. All these things are leaning on the same relationships. All right, can we scroll up some? All right, let me see if I can write this a little better. Well, we have t is a real number and equal to the length of the intercepted arc. Of an angle that measures t radians. And p is our ordered pair of -1/2. square root of 3 over 2. Point on the unit circle that corresponds to t. It says try to find the trig functions at t. All right. Okay, still see writing. All right. So once again, t is a real number equal to the length of the intercepted arc of an angle that measures t radians, and p equal to -1/2 square root of 3 over 2 is a point on the unit circle that corresponds to t. Find the trig functions at t. So easiest ones to find for us is sine and cosine. So once again, sine is y, cosine is x. So, the order pair is always x, y. All right, so now the work behind getting tangent. Let me just erase some of this stuff. All right, so you do y over x. And what I was pointing out here, if you forgot by some chance, division, your fraction rules and division and everything, this fraction bar is the same thing as this divisional sign. So I went from writing it vertically to horizontally. And then whenever you divide it by a fraction, you multiply it by the reciprocal. So that's the square root of 3 times, the square root of 3 over 2 times -2 over 1. You have to flip it and multiply. So your 2's cancel, and that will leave you with negative square root of 3. All right, any problems with tangent before we move to the next 3? All right. So cosecant is the inverse of sine. So we take sine with the square root of 3 over 2 and flip it. Now we have 2 over the square root of 3. Don't forget to rationalize your denominator. So we multiply top and bottom by the square root of 3. And that'll be 2 square root of 3 over 3. Secant is the inverse of cosine. So cosine was -1 over 2. Flip that, that's -2 over 1, which is just -2. Then the last one, cotangent. So we could go back and put x over y, or we could just take the inverse of the result of tangent. So that's what I did here. No tangent, square root of 3 over 1. So just went ahead and get a better color. Just flip that. So that's negative 1 over square root of 3. Rationalize your denominator with the square root of 3, and so that give you negative square root of 3 over 3. All right, questions? Any questions? All right, let's scroll up. So the next one, find the values of the trig functions at t equal to pi over 2. All right, so pi over 2 is 90 degrees. Coordinates of your 90 degrees is 0, 1. I just thought about something. Did I send that unit circle? I meant to send it. Somebody give me a head nod, yes or no, if I sent that unit circle to you guys.
I don't think so. No, sir.
Okay, thank you. I'll do it before the day is out. Okay, thank you. I meant to send it just for anybody who wanted it. But yeah, if you were to look at your unit circle, pi over 2 and 90 degrees, when we talked about it last class, are the same thing. So the coordinates of 90 degrees is 0, 1. And so that means x is 0, y is 1, as far as your coordinates are concerned. So from there, you just go ahead and fill out the relationship as we know it. So here, sine of pi over 2 is y because, is 1 because that's y. Cosine of pi over 2 is 0 because that's our x. Tangent of pi over 2 is undefined because that's y over x, which is 1 over 0. Cosecant, which is the inverse of sine, is going to be 1 over 1, which is just 1. Secant, inverse of cosine, that will be 1 over 0, which is undefined. You're inverting 0, which is 0 over 1, so 1 over 0 will be undefined. And then cotangent would be 0, because that would be 0 over 1. Any questions? All right, scroll up. All right. So your domain and range of sine and cosine. Your domain is negative infinity to infinity. Range is -1 to 1. Inclusive. Remember, the brackets mean inclusive. So we just saw that it is possible for sine to produce, 1. So once again, you can plug in anything. That's your input. You can plug in anything to sine and cosine, but your range of what you would get out is from -1 to 1. And so if you were to look at the sine curve and the cosine curve, it's a wave, and it will go at the peak up to 1, down to -1, and then but it goes on to infinity to the right, on to infinity to the left. Lets you know that you can plug in anything to cosine and sine. All right. Problems with that one? Scroll up. All right. So we have two even functions, the two inverse functions, cosine and secant. Basically, if you were to plug in -t, the answer for cosine of -t is the same thing as the answer for cosine of t. Same thing when it goes to secant. So they're considered even functions. Your odd functions are the other ones, the other 4. So when you plug in negative into the application of sine, tangent, cosecant, or cotangent, it's the same as having negative sine t or negative tan t, negative cosecant, and then negative cotangent. All right, any problems, any problems? All right, so putting that into play, says find the exact value of each. Cosine of -45 degrees is the same thing as cosine of 45 degrees. So it's an even function. Remember, that's the relationship we just introduced. So cosine of 45 degrees is the square root of 2/2. So even though you have a copy of the unit circle from me, don't forget I did give you that chart of familiar angles. So 30 degrees, 45 degrees, and 60 degrees is on that. And so you could always reference that as well as far as this is concerned. Next one, tangent of -π/3. That's the radians value for 60 degrees. So it's an odd function. So this angle, right? I mean, not this angle, the sine that's on the inside can be pulled actually to the outside, and you can find the tangent of π/3, which is the square root of 3. So that negative that's on the outside is the same one that's on the inside of the tangent, the same one that's out here on the outside. And then, like I said, what you do is then find the tangent of power 3, which is just square root of 3. All right, last one, same thing. Sine of negative 60 degrees is odd. So bring the negative to the outside, find the sine of 60 degrees, which is square root of 3 over 2. So it's going to be negative square root of 3 over 2. Any questions? Any questions? Sorry about that. I have to plug in this charger. All right, can we scroll up? Very good. All right, so periodic functions. Periodic is the behavior of the function that repeats infinitely. Then it says a function f is periodic if there exists a positive number p such that, and basically just saying that p is increments. And as far as p goes up, it'll always be able to be repeated by f of t. And you'll see what I mean. Second, it goes back to, remember we were talking about the rotation. And at some point, you know, you talk about your unit circle, you know, you go around one time. If you have a point right here where you go around again, that point is right there. But if you add 360, just go back to your reference angles and all of this stuff like that, the coordinates will still be the same. So, you know, all these things are just repeating. So the behavior repeats as well. It says the smallest positive number p for which f is periodic is called the period of f. Let me plug in this charger real quick. All right. Let me know if I scroll up too far, if anybody's still copying. All right, so looking at our periodic properties. We have sine of t plus 2 pi. Same thing as sine of t. And the same thing with cosine. Remember, we just mentioned that cosine has the same period. Now, we didn't say it has the same period, but we just mentioned about 2 pi. Let me go back. Oh, the range. Never mind. I was thinking about something else. Okay. So, but sine and cosine have the same period. Period of 2 pi. Tangent has the period of tangent and cotangent has the period of pi. And also, I didn't mention it, but I wrote it right here. Cosecant and secant also have the same period of 2 pi. All right. Everybody good? All right. So don't forget also, I didn't write it here, but we talked about it before. 2 pi is the same thing as 360. Pi is the same thing as 180. As far as degrees are concerned. So find the exact value of each. So we have cosine of 420. And if it's larger than 360, what we can do is subtract 360 from it to see what's a smaller value that's under 360 that we can possibly relate to or be more familiar to us. And so 420 minus 360 is 60. And if we were to take the relationship we just introduced, cosine of 60 plus 360 is the same thing as cosine of 60. And so cosine of 60 is 1/2. All right. Going to the next one, same thought process for sine because it's 2 pi, but we're dealing with radians. And we have this fraction of 9 pi over 4. So we need to convert 2 pi into a fraction that has a denominator of 4. And what did I write? Could have worked that a little better. Write this like this. All right. So turning 2 pi into a denominator has pi over 4. That would be 8 pi over 4. And so we see that it is less than 9 pi over 4. So we'll just subtract that. We see we get pi over 4. Oh, that's what I was doing. I just didn't write it clear. So we just spin pi over 4. And so do the same relationship. It's right here. Remember that 8 pi over 4 is our 2 pi. So that simplifies to just sine over pi over 4, sine of pi over 4. And that is just 2 pi over 2. All right, any questions? Any questions? Okay, thought so. All right, so that's it for 5-4. So looking at your assignments, 5-5 and 5-6 deals with the graphs of sine and cosine. Well, 5-5 is graphs of sine and cosine. 5-6 is graphs of tangents. Oh, and the other ones and the reciprocals. So check that out. use a graphing tool to help you find the answer. I'm not going to ask you to graph any of your trig functions, but you should be familiar with them. You should have a graphing tool. If you don't have a graphing calculator, feel free to use something like Desmos or something along those lines to help you find the answer and everything like that. I believe they ask you, a lot of times they just graph and then ask you to pick out the right graph. They might ask you about some shifts and everything. But normally when it comes to graphs, I pretty much just let you guys attack those versus me trying to draw them and everything like that. And then if you have any questions, feel free to ask about them. So yeah, that's how we'll attack the graphs and the graphing. Let's see, we got 5.7 applications. So let's go ahead and get started in 5.7. And then find a good spot to stop. So 5.7 inverse trig functions. All right, so it's denoted by sine, and you have this -1 superscript, like an exponent. So that's be sine inverse of x. And so the sine inverse of x is the same thing as if I wanted to solve for, so if I had this right here and I wanted to solve for y, I would apply the sine inverse to both sides in order to cancel out the sine on my y. And then I would have sine inverse applied to x. Also notice that here, it sets up my domain and my range is going to be flipped. So my domain is -101 range. And we'll see, I'll show you when we get there. All right, questions? Scroll up. All right, so find the exact values of sine inverse of x. So first thing we're going to do is we're going to let theta be equal to sine inverse of x. And then going from step 1 to step 2, notice right here it says sine theta is equal to x. But that goes back to what I was saying about being able to solve, and sine and sine inverse cancel out each other or undo each other. So if I want to take this to this right here, then what I would do is apply the sine to both sides. And that will cancel out the sine and sine inverse on the right, leaving me with just x. And then on the left, I would have sine theta. So that's how they get from theta sine inverse x down to sine theta equal to x. And then this is going to be key here as well. Making sure we don't go outside of that domain of plugging in values for theta. Can't go larger than pi over 2 and no less than negative pi over 2. And then we could use the exact values in the table. Copy that. And then here, this is just a diagram, showing you where the range of domain actually exists for sine inverse. And that's just in the first and fourth quadrant. We're going from power over 2 to negative power over 2. Am I still copying the purple? All right, so let's use that. In the next example, it says find the exact value of sine inverse of square root of 2 over 2. So we're going to follow these steps right here, 1, 2, 3. First thing we do is set theta equal to, what we're looking for, sine inverse of square root of 2 over 2. So that means sine theta is equal to square root of 2 over 2. Once again, we're just following the flow here, what they told us. Then step 3, we can go to the table and we look for square root of 2 over 2. And we see that that's power 4. And that's our answer. So sine inverse of square root of 2 over 2 is equal to power 4. All right, any problems before we look at the next one? All right, follow the same pattern. Theta is equal to sine inverse of negative 1 over 2. So that means sine theta is equal to negative 1 over 2. Then go to your chart, find negative 1 over 2. And we see that that's negative power over 6. And so that's how we get the answer. That's good. Any problems, any problems? All right, so very similarly, dealing with the inverse of cosine. Let me see one thing. Go back, okay. Yep, that's- So we see cosine inverse. Our domain is going to be the same, but then our y only going from 0 to pi, which is quadrants 1 and 2. And once again, we're going to use this chart just like before. So we're going to follow the same 3 steps. All right, can I scroll up? All right, so once again, we're going to follow the same set of instructions. Find the exact value of cosine inverse of negative square root of 3 over 2. Set that equal to theta. Bring cosine over. We're looking at cosine theta of negative square root of 3 over 2. Then we hit the table. Square root of 3 over 2 is right here. So that's going to be 5 power over 6. Any problems, any problem?
Would you mind going back up to the table? Okay, thank you.
Not a problem. Let me know when you finish with that table. All right, are we good on the table? I said yes, yes, so. All right. I think this is our last. Oh yeah, we got to do the outside ones. Okay, so let's look at tangent, inverse tangent functions. Same type of flow. As we have our domain and range set up. And we have our chart right there. All right. So once again, follow the same pattern. End up having tan theta is equal to square root of 3. Go to the chart. Square root of 3 lines up with pi over 3. And that's the answer. All right, questions? Any questions? So this is a good place to stop. We can finish 5-7 next class and then do 5-8. And especially since you have 5-5 and 5-6 now as far as the graphs are concerned. So like I said, it's a good place to pause versus getting caught up in another new topic in this section. So before we close out, is everybody good?
Yes, sir.
All right, sounds good. Thank you for that. So you guys have a good one. Be safe. I'll see you next class and we'll look to finish out chapter 5.
Have a good one.
Thanks for doing the
Have a
same.
good
Take
day.
care. Thanks for doing the
Thank you
same.
very much. Goodbye.
Take care.